Hey class, the next thing we're going to be looking at is writing to an XML stream, but we need to back up and say, what is XML? XML stands for Extensible Markup Language. It was designed to store and transport data. So it was designed to be both human and machine readable. Here's an example. You can see in this example, we have our XML header, and then we have a begin tag and an end tag specifying that this is going to be a note. Within the note, we have a to tag, a from tag, a heading tag, and a body tag. We can display this XML file as a note. Our application knows how to interpret it. Or we can just look at the XML file itself. Here's another example XML file with repeating entries. This is more common. We see that our XML root is our breakfast menu. And within our breakfast menu, we have different food items. Each food item has a begin tag and an end tag. And within that food item, we have different data elements with values. Each of these different data elements has a begin tag and an end tag, and the value of the data occurs between those tags. So XML is a tagged language, much like HTML, a markup language. Why do we want to look at it? Well, it's very important in many different IT systems, and it's used quite heavily for distributing data over the internet. It's important for software developers to have an understanding of basic XML. This W3 Schools tutorial goes much more in depth in XML than we will in our class. What we will be doing is writing an XML format file and reading from an XML format stream file. In an introduction, XML, again, stands for Extensible Markup Language. It's a markup language like HTML, but it was designed to store and transport data. The tags give it the capability to be self-descriptive, so it's a little hard to understand XML, but it doesn't really do anything. It just has these, it's just this language that says, here's the data, and here's what the data elements are called. The field names being supplied in the tags. So if we look at this XML information, it's very self-descriptive. We see it has sender information, it has receiver information, a heading, and a body. Someone has to actually write the code to process that XML to make it display this note. Now there's some differences, of course, between XML and HTML. XML, as you can see, was designed to carry data. So its format, its focus is on what the data is. HTML was designed to display data with a focus on how the data looks. XML tags are not predefined like HTML tags are. So if we have data to display using an XML format, we'll just supply the tags as our own field names. So let's do that. I have our project from our last video open where we have a work with text method, and I'm going to come to the end of my work with text method and declare a new method, work with XML. Now in our work with XML method, first of all, we're going to define a file to write our XML data out to. Our file name is going to be a string. and we're going to combine our current directory with the file name streams.xml. Notice when we were working with a text file, our file type was .txt. Because we're working with an XML file this time, we're using .xml as our file type. It's important for us to follow standard file type naming conventions like that. Okay, now we're going to go ahead and create a file stream. And our file stream is going to be called XMLFileStream. And it's going to be based on the output of our file class create method using our XML file information. So the create method will use that information to create our new file. Now we're going to wrap that file stream in an XML writer helper. That helper is going to automatically indent those nested elements. Each field that we see in an XML file with a begin tag and an end tag is referred to as an element. Our class name is going to be XML Writer. That's our XML Writer helper. We're going to call our XML Writer XML. Now, our XML Writer requires certain pieces of input as parameters. First of all, it wants the name of our stream, and then we can supply new settings, XML Writer settings, as we instantiate this XML helper, and we'll say that we want to set our indent equal to true in our settings. Now we have to write out that XML declaration, that root heading, and that's called the start of the document. We use the XML write start document method. Then we actually need to write out that root element. If we refer back to that XML example, we'll see that first we're writing out this XML start document, the declaration. Next, we're writing out this root element. So that occurs at the beginning of our list. To do that, we'll take our XML object and tell it to write a start element, and we want the start element to be call signs. Now we're going to enumerate the strings, writing each one to the stream. So our for each loop, just like we did for our text file, we're going to read through our call signs array, and for each entry in the array, we're going to output that entry to our XML file. We do that using the write element string method, and this is a call sign element, and then we'll supply the data for that element. Now, as we complete our for each loop, we've written out all of the entries in our array. Let's write the close root element. Remember that end tag. Write end element. And finally, we'll close our XML file, and then we'll close our XML file stream. And lastly, we'll write an output line. And our output line, arg0, should be XML file. And replace our argument 1 with new file info on our XML file. And we want to find out the length of that file. Remember, our length requires an instance of the file info class. We're creating an anonymous instance here with the new. It doesn't have a name. It'll just be created long enough for us to use to get the length from it. After that write line, let's write another line out, and we'll use the file read all text, and we'll use our XML file to read it all and write it all out to the console. Let's try running that. In our main, let's comment out our work with text call and add in our work with XML call. And we'll run this. I'm going to press Control F5 so that it will stop for me. And I see that my XML file has been output. Here's my XML header, my root, and each individual item that I've created. Every element being saved in the XML file, just as we like. Now we could set a debug breakpoint for this. Let's do that. I'm going to set it. Let's do it where we can do it way up here at line 38, where we allocate our XML file stream. I'm going to start running. And as I start running, I can see the debugger information down here. My first object that I'm creating is my XML file. I'm going to step into my process here. Once my XML file is created, I can categorize that as a stream. Sets up my file stream object. I could look at individual pieces of information about my file stream object. And next, we're going to create our writer helper for that stream. The XML writer helper is the one that knows about writing out the start document, so we'll let it do that function. It's going to write out our start element for our root element, and then we'll go into our for each loop for each item in our call signs array. We could expand that, see all of those items in our array. we'll step into our for each statement and write that item out to our file. Every time we have one, we'll write it. We can see what's getting written down in our locals window. And then finally, we'll write our end element, close our XML file so that it's properly closed by the operating system, close that stream object so that it's not taking up resources, and then we'll write out our message and our file. Now, I see everything on my console screen, all looking good. My debugger ready for me to continue. And that ends out my program. So you can see how we can take a collection and very simply write it out to a text file. But we can also a little bit more complicated. We can also create an XML file fairly easily from that with all of the required formatting for an XML file. Now I want to go ahead and update my work with the XML method just a little bit. Let's try these changes. We're going to make things a little bit more industrial, a little more heavy-duty strength. In our work with XML method, let's create our objects as null objects. Our file stream object we called XMLFileStream. And we created, and I'm going to set that equal to a null value. And next, our XML writer we called XML, and we're also going to allocate a null XML writer. Now you can see that that caused a couple of errors further on in our code. Don't worry about those yet. We'll get to them. What I want to do is implement a try block. Working with files can be fraught with errors because we're working with the file system of our operating system. So we usually want to have code that works with files embedded in a try-catch block. Now I'm going to start out indenting my code for my try block. First of all, we'll keep our string that creates our XML file. Now, in our file stream, it's already been allocated, so we just want to remove the data type, that file stream specifier, from the beginning of our command, and then that'll eliminate that error. Same thing with our XML writer. I'll indent and then remove that data type because this object has already been declared and allocated. Now these additional lines of code all need to be indented. I'll get all of these. Oops. I want to select them all and press Tab to indent them all at the same time. And after our right line, I want to have the closing curly brace for the end of my try. And then I'm going to add a catch block. Remember, our catch block says if an error occurs, an exception, catch that for me. And if you would, wrap up all the information about it in an exception object called EX. Now within my catch block, let's use our exception object to display some information. If the path doesn't exist, the exception will be caught. and we'll write it out. We'll use our exception object to get the type of exception to display. And then we'll add this, and we'll use our exception object again to gather its message information to display. Now that'll be the end of our catch block. But we're going to add a finally block. Remember, the finally block executes no matter what. If our try is successful, our finally block will execute. If our try is unsuccessful, our catch block will execute, and then our finally block will execute. So let's do some cleanup work in our finally block. If our XML file has not been released, if it's not equal null, let's dispose of that object. We don't want those resources laying around. Let's tell people about how great we were. The XML writers, unmanaged resources have been disposed. That'll end our if block there. And then we're going to do another if statement to check to make sure our XMLFileStream resources have all been released. And if they haven't, we'll use our XMLFileStream dispose method to make sure they are released. If we run into some sort of error, we might not execute our close function, so we want to make sure we're releasing these resources. Now, that should take care of it. So if any resources are left hanging around, we're going to dispose of them. That'll be the end of our finally block. And the end of our working with XML method. All right, we still have our work with XML method executing, so we can go ahead and set a breakpoint on our try block so that we can see how that impacts things. We should see that it doesn't make much difference to us as long as things are working properly. We'll get our current directory and then combine our file name with that, create the file, create our file stream, write out our start document and our root element, and then each of our individual collection elements. Then we'll close our file and close our file stream. We'll write out our information and our file. And now our try block is complete, but we'll execute our finally block because remember we execute it no matter what. If our XML file has left any resources laying around, we'll dispose of those. And look, it looks like it has. We've gotten rid of them. And also for our XML file stream, if there's any unmanaged resources, which there are, we'll dispose of those. So we've cleaned up after ourselves now. And if we have some sort of file system error, we'll catch that too and let our users know without our program canceling because we've implemented our try-catch logic. Let's finish this up, and I'm going to go to Solution Explorer because I want to check in all of my changes. Now at this point, TFS has noted the fact that I've updated the program.cs file and it's checked it out automatically. I didn't have to do anything, but it was checked out to me because I'm updating it. This way TFS can warn me if somebody else has also updated this file, and it can warn them so that we can make sure to manage our changes appropriately. I need to check these changes in, so I'll check in this file. Now I could do that at the solution level, but I know my program.cs was the only file that it's changed, so I can check it in. Add XML error handling and check in. My check-in is complete. If I wanted to, I can look at the Source Control Explorer here on my desktop and see all the different projects that I have checked in to my TFS repository here. If you notice, most of my projects are grayed out. That means they're on the TFS server, but they're not available on my local workstation. The ones that are available are the ones that I've been working on in this lesson. So you can see how TFS has these available. If I were to click on them, I could automatically get latest project, which it did for me automatically. There's also an icon for that up here. Get latest version, and that will download these projects and all of its files to my local machine so that I could work on them from my local machine. Notice I could look at the project, view the code, execute it, do whatever I wanted. TFS would never mark any of those files checked out unless I changed one, and then it would lock that file with a shared lock to say this file is checked out. So TFS helps us to work with others so that we can manage our changes without having a negative impact on other developers. I think that's it for this video. Thanks for looking at XML.